speaker. His name is Michele Bertoli. Go ahead and switch your laptop, Michele. He's going to talk to us about software testing. Please give a warm applause to Michele from Facebook in London.
Hey. Wow. I'm Michele. I work at Facebook. I wrote a book about React. If you want to improve your React skills, you might find it interesting. And follow me on Twitter if you want to hear more about me, and I'm going to post the slide afterwards. For the next 30 minutes, I'm going to talk about testing. That's what you would expect. But first of all, I'm going to ask you 3 questions. And my next slide depends on the answers that you're going to give me, so please answer carefully. So how many of you think that tests are useful? Like, I guess everyone, fair enough. But how many of you habitually write tests when they write code? They don't submit a PR, oh my God. Okay, good. But yeah, final question. How many of you think that they have the right amount of tests in their code base right now? Okay, perfect. That worked, thank you. So basically, I always see this pattern. There is this huge gap between people that actually think that tests are useful, but the people that actually write tests and they think that they have enough tests in their code base is very small. And this talk is about figuring out why, the reasons why there is this gap, and see if there are some solutions. Luckily, there are. This tweet from Dmitry Abramov is a Facebook employee as well as a maintainer of Jest. He says, "Said this thing I hear from engineers, we aren't writing tests right now because we are focusing on building features. I don't want to enter the argument if you should write tests or if you shouldn't. That doesn't matter now. What matters, the point here is that if engineers think that while they are building features, they cannot write tests because tests are slowing them down, then we have a huge problem, because tests should make them faster." And I guess the reason is testing is actually really, really, really hard. And I want to show you some reasons why I think testing is hard. It's time-consuming. If you write proper tests, you end up spending more time writing tests than the time you spend writing code, which is not bad in principle, but engineers tend to feel less productive if they don't push code to production. Therefore, they're going to write less tests. Test environments are complex to set up. For example, if you bundle your JavaScript application with Webpack and you load any non-JavaScript module, then Node is going to complain when you run the same code base in Node. For example, if you load the CSS with the CSS loader, then it's not straightforward to make the same code work in the Node environment. Tests give you a lot of false negatives. And if you ever wrote an end-to-end test, then you know what I mean. You have your application working in the browser, it works. You try to make an automated test to test actually the same feature, and you cannot make the test work, which is very frustrating. You spend a lot of time, maybe an HTTP call that fails, or you try to access a DOM property that is not in the DOM yet. A lot of reasons that gives you a lot of false negatives. If we all agree, we can call it testing fatigue from now on. However, testing is actually really important. And if you think that my next 3 slides are obvious, that's good, you're fine. But since there is this huge gap between people that would love to write tests, but they don't actually write tests, I guess it's important to iterate on these concepts again. These are the reasons why I think testing is important. First of all, you can catch bugs with tests. So if you are building a feature and you test it, then you can make sure it works as expected before it hits production. And it's also easier for you to find the edge cases when you have a test for a feature. Tests give confidence to you and to your reviewer. So if you submit a pull request and it's baked by tests, then your reviewer are going to be more likely to accept it, because tests are is a guarantee that the code you submitted works. Also, if you have to modify or refactor some parts of a legacy code base, then if it's covered by tests, then you can concentrate on the feature you're working on, and you don't worry about breaking anything else, because tests are going to tell you. Last but not least, tests can be your documentation. I'm not a huge fan of like written documentation, readmes, and all of that kind of stuff because they become outdated very, very quickly. But if you use tests to document your code, then they have to be up to date. Because if you update your code, but you don't update your tests, they're going to fail. When I find a cool repo on GitHub, for example, what I usually do, I go straight to the test folder because actually tests tell the truth, and I suggest you to do the same. It's important to mention that the way engineers are approaching to testing is changing over time, and here are some examples. Dan Abramov, he's working at Facebook as well in the React team. He says, unpopular opinion, component unit testing is overrated. And I used to do done-driven development, as many of you, I guess, for a long time, and I was pretty disappointed when I've seen this because like, I'm really into testing. But I get his point. He says React components should be very simple, and they change very often, so there should be better ways to test React components, and we'll see one of those later. Guglielmo Roach from Zaid, they're doing super cool stuff with JavaScript. You should follow him. He says, write tests, not too many, mostly integration. So again, unit tests are losing their appeal like year after year. Because if we go back to 2009, then the test pyramid was saying you should unit test all of your code because it's cheap and fast. Then you test some services, some integration tests, because obviously they are more expensive but more effective. And then you test your UI to make sure the application actually works. And Dmitry Abramov last year proposed a new pyramid of testing, which is more modern. You cover all of your code base with static analysis. So with Flow, you can make sure your functions receive the right parameters. With ESLint, you can make sure you are not accessing undefined variables. Then you write some JavaScript tests, not too many, and you don't care about the definition of the test, like unit test, integration test, who cares? You should concentrate on the value that test provides to your code base. And you're not going to get rid of WebDriver tests. That's it. And one tool, which I believe is actually trying to solve all the problems we've seen before and the reasons why the engineers don't write tests, is Jest. And it has been built with the developer experience in mind, and it tries to make tests painless. And it's my favorite tool right now, and I'm going to show you why. It's a zero configuration test environment. So you install it, you run it, it works. For a lot of use cases, you don't have to write any configuration file. It's fast, because it runs tests in parallel, and tests are sandbox, so they don't leak the state to each other. And this is super cool. It gives you an instant feedback. So if you run Jest in the watch mode, so it keeps on running and it keeps on listening, as soon as you save the file, Jest is smart enough to understand which files are changed and which files are affected, which tests are affected by those files. So it runs the test only for the files that actually change. And also, it runs the fail test first. So if you have 1,000 green tests and then one red test, when you run Jest again, then it's going to run the red test first, so you don't have to wait for the 1,000 green to pass again. And if this, in conjunction with the bail option, which basically stops Jest as soon as one test fails, gives you like the fastest feedback loop you can imagine. So you don't waste your time. It has built-in coverage report, powerful mocking library. This basically is a complete product. If you compare it, for example, I guess many of you are using Mocha, but if you use Mocha, then you have to install Chai for expectation, Xenon for Spy and Mocks, and then JSDOM, and then Istanbul for code coverage. And not only you have to install these packages, but also you have to keep them updated, which is pretty painful. And it works with TypeScript and any compiled to JavaScript languages. But if you were to ask me, like, one single reason to use Jest is snapshot testing. And we see how it works now. So the first time you run Jest, it takes a picture of your components at the given point in time. Then you change your components, you add new features, you run Jest again, Jest takes another picture, and it compares the two pictures, and it tells you what changed. It doesn't tell you if you did something wrong or something right. It just tells you, hey, your components are changed. And I said pictures because they are not actual pictures, as you will see. They are text files. But that's a good example of how it works. So let's see a real-world example. We have this button with 3 properties. It's super simple: disabled, primary, and text. It renders a button component, a button element. And the primary property affects the class name. So the class name could be either primary or secondary. Then the disabled property determines if the disabled attribute is true or false. And then you have the text of the button. If you had to test this component with Enzyme, then your test would look like this. For those who don't know, Enzyme is a set of test utilities to test React components. It gives you some functions to render the components and some fancy functions, actually, to access their properties, the state, and make assertions like this. So there is the shallow functions, which is really convenient if you want to unit test your component, because it renders your trier components only one level deep. As soon as you get back the shallow wrapper from Enzyme, then you can write expectation. So you expect the property disabled to be true, the right class to be applied, and the text to be there. But if you think about that, there is no problem with this code, but if you think about that, this is like a big chunk of code, and it's a super simple component with only 3 properties, and we are testing one combination of those properties. If you think about more complex component, and you had to write like all the different states that this component can have, then you would spend more time writing the test than the component itself. And if you would change the component, like, I don't know, removing a property, then you would break multiple tests. So the component would become less flexible, which is actually bad. And here is where snapshot testing comes to rescue. You install a special render called React Test Render, which is able to render a component into a serializable tree. As soon as you get the tree back from the renderer, then you expect the tree to match the snapshot. That is it. The first time you run it, it generates this text file. So it doesn't work with picture, it works with text files. And this text file actually is a human-readable version of the output of the render. In fact, you can find like the button element, the class name, disabled property, and also the text of the button. OK, now suppose you want to change the class name from btn to button. If you would do that, and you had like Jest running in watch mode, Jest would tell you, stop. The class name is changed. Is it something you wanted to do, or is it something you did by mistake? If you did it by mistake, just go and fix it. Otherwise, Jest presents you a list of actions to do. And the second action is actually the action to update the snapshots. So if you would press U, then your snapshot would contain the new class name, button. That is it. So this is, for me, is the best developer experience to test React components. You just write your components, just tell you what changed. You decide if it's right or wrong. If it's right, you press U. That is it. When I talk with people about snapshot testing, there are some common misconceptions. And I want to give you the answer right now, so as soon as my talk is finished, you can migrate your code base to Jest without like any problem. Should I commit my snapshot? Of course you should. There is a lot of confusion about this, but if you don't commit your snapshot, then it doesn't make any sense. The snapshots should follow the life cycle of your components. And as soon as your components change, the snapshots change as well. And if you work on the same component like in 6 months' time, then you still want to know if something is changed from the previous version. How is it different from visual regression testing? It's completely different because visual regression testing usually takes screenshots of your application, and then it compares the 2 images pixel by pixel. While Jest, as we've seen, works with text files, which makes it easier to compare text files, and also faster. Does it work only with React components? No. It's the best use case for snapshot testing. I suggest you to start from that. But it works with any serializable value. For example, you could create a snapshot of your Redux state, and then you fire an action, you dispatch an action, and then you can see what changed. Also, the second reason why I love Jest is because you can extend it to make it fit better for your application and your needs. And what I've done here a couple of weeks ago, I built a library to test style components with Jest. And I want to show you it as an example to how you can extend Jest to make it work better for your application. As we've seen this morning, style components is the best way to style React components today. You import the style function from style component package, and then you use the button function to which you pass some CSS. And you get back a button component that you can use. However, if you run Jest snapshot against that component, you're going to see something pretty weird. In fact, you're going to see a class name there. And you didn't put any class name. Style components did. But let's see what Jest can do for us and how we can extend it to make it work better with style component. So first of all, the question that Jest can answer is, did my component change? And it can still answer this question even with style components. Because, for example, if you render a div instead of a button, Jest is going to tell you, hey, the component that you are rendering is changed. However, when we work with style components, we want to know if the styles are changed. And Jest can partially answer this question. So did my style change? Yes. Every time you change your style, style components recalculate the hash of your styles, and it uses this as a class name. So you can assume that if the class name is changed, then your styles has changed as well. But that's not enough, actually. We want to know, how did my styles change? And this is what my package does. So it's composed by two parts, and the matcher and the serializer. And you can add as many snapshot serializers as you want, and they all receive the serialized tree. And they can do whatever they want with it. So for example, in this case, we want to put the style as well as the render component to the snapshot. Also, you can extend expect with your own matchers. So before, we were using the to-match snapshot function, while now that we have extend expect, then we can use to-match style component snapshot. Which actually tweaks a little bit the output to make it less noisy for this use case. So now, if you would run Jest again, you would have this. You would have the style and then the render output as well. And this is pretty useful when you work with style component, and it's also pretty easy to write. Now, if you change the color from blue to red, for example, then Jest can tell you, because it can compare the snapshots. And this is pretty useful for style components. So you can make sure that you don't change the styles by mistake. Cool. Next step, follow FBJest, start Jest on GitHub, and if you want to migrate very easily, you can run a code mod. A code mod is a tool that can read your source code. It transforms it into an abstract syntax tree, and it applies all the transformation, for example, from Mocha, from Jasmine, Ava, the other test frameworks, and then the output is actually source code, which uses the Jest functions. It's super easy, it works. Cool. 1 sec. So we have seen how Jest solves most of the problem that we have with testing. And so, OK, we are done. No, I wanted to go a little bit further and see actually if there were better ways to make developers happier when they had to write tests. Because we started from the point that, you raised your hands as well, where everyone thinks that tests are useful, but very few of us write tests. So I wanted to see if there were better ways. And I came to a conclusion, which is this one. Is the best testing strategy is not writing tests. But I don't actually mean not having your code base covered by tests. I actually mean not writing tests. Even if this is also true, you can't have failing tests if you don't write tests. But I don't mean this. I mean, you still have tests, but you are not the person that actually writes the tests. And the first tool that I built, and then I want to show you, is snapguidist. And I started from this point. This is an example of style guide, and if you don't have a style guide, you should. A style guide is a great way to share a component library with the rest of your team, with the other engineers, developers, and have a common catalog of components. In this case, we have a button, like primary, secondary, disabled. We show the button in its different states. And when it comes to write tests for this button, we actually do the same. We test button primary, we test button secondary, and we test button disabled. And every time you do the same thing twice, it's wrong, with like when you have a laptop in front of you, right? That can do the work for you. To create my style guide, I use React Style Guides, which is a great tool to automatically generate style guides out of your components. You just define the different states that they can have in a README file, and Style Guide is going to extract the code from the README and generate a style guide for you. SnapGuidist adds snapshot testing to Style Guidist. And let's see how it works. So this is a style guide built with the React Style Guidist. And you have basic button, big ping button. You have even a counter button, which you can click on. So it's a live style guide. It's a pretty cool tool. But if you know how style guides work, you would notice that there is a green line below every component. And the green line is what SnapGuidist adds to React Style Guides. And the green line means that a snapshot has been created for the component, and it matches the current state of the code. So we have this placeholder component, which takes a type property, one of animal, beacon, beard, and bear. And if we open this, we can see the code. So placeholder type beard. And if we change it from beard to bear, then we're going to see a bear. Actually, am I connected to internet? Yeah. We should see a bear. But what matters is that the line is now red, which means that the code doesn't match the snapshot anymore. You can even expand the output of the snapshot and see what actually changed. And if you are happy with the change, we want to stay with the bear, then we update the snapshot. We didn't write any test, and we have all of our components covered by snapshot testing, which is cool. And, but this actually is creating real snapshots, real files that you have to commit. It's not only a UI thing. Cool. If you are using Storybook, which is another great tool to generate style guides out of your components, then there is StoryShots, which gives you basically the same functionality. The second tool I want to show you is React Fixit. And again, I started from a very simple point. When a user tells you that there is a bug in your application, I guess what you usually do, you try to reproduce the issue in the browser. So I don't know, you log into production, and you try to follow the same step that the user takes. And if you are lucky enough to reproduce the issue, then you collect all the information from the browser. So the error that has been thrown, the stack trace, the component that failed, the state of your Redux application, whatever you need to reproduce the issue. Then you go back to your test environment, and you try to write a failing test with those conditions. If you're lucky enough to being able to reproduce the issue in the test environment, then you fix the bug and you celebrate. And again, you're doing the same thing twice. That's wrong. And I thought, who has all the information that we actually need to write the test? The browser. So why don't the browser write the test for us? Let's see how it works. We have this simple React application, which is with a bomb button. When I click that button, the application is going to explode and throw an error, actually. But since there is React Fixit listening to it, you're going to see like something more than just a red error. So I click on the button, the application throws, and you see the error. But there is also a test snippet, because the browser had already all the information to write the test snippet for me. And if we go to the console now, we can see that this application has one test, is green, is passing. So we want to add this test as well to our application. And so there is this test, which is passing. So we are not covering the case where it explodes. But if we copy the test snippet that the browser gave us, then we have a failing test. which covers the same case with the state, the component that failed, the function that failed, everything. And if we now fix the bug, and usually I fix the bug by removing the code, it always works with my code. And in fact, if I remove the code now, let me just refresh, tests are green, and we didn't write any tests again, and we have our application covered by tests. A quick recap. Find a painless way to test your application. If you don't write tests because tests make you slower, then it's not like testing the wrong thing. It's the way you are writing tests. So you are using the wrong tool for your application. You are not getting the most out of your tool. So like use the right tool, for example, Jest. Extend your tool to do whatever you need, for example, Jest-style components. Write more tests, obviously. This is what this talk is all about. You should write all, like we all should write more tests. And last but not least, have fun. Like testing is really fun. And take this, if you cover your application by tests, you can ship on Friday afternoon at 5 and then enjoy your weekend, which is a great thing. Any question?
Thank you, Michele. Thank you very much. We have time for 2, maybe 3 questions.
Awesome.
Willing to help me with
one there?
running the mics?
I wonder.
No volunteers?
Okay.
Hello.
Hello.
Yep. Do you have any suggestions for setting up cross-platform user interface testing in the case of React Native, for example?
Oh yeah, Jest works with React Native very, very well.
Even from the perspective of the user, like end-to-end testing, like for example, something you would do.
You mean like end-to-end testing, like functional testing, like spinning up a browser, like clicking on the
exactly.
thing? Okay, no, Jest cannot do that at the moment. Right. You should use like WebDriver, things like that, Selenium.
Okay, thank you.
Thank you. One more question?
Are there any plans for Jest to support IDEs like IntelliJ or WebStorm in terms of running the tests within the IDE?
Oh yeah. That's. I've seen a tweet recently from one person which is actually working in the Jest team, and they're actually building an integration for now with Nuclide, which is a set of plugins on top of Atom, where you can actually see the result. Like you can hover your test, and then you can see the output of the snapshot.
Okay, cool.
So that's really cool. So obviously, more things will come. There is an integration with VS Code, but like more integration will come for sure.
One last question.
How would you like to do test-driven development with Jest, or is it not possible? And what do you recommend instead?
This is a very, very good question that actually my friend Lucas asked me different times, because there is a problem. With Jest, you can do test-driven development. But with Snapshot, it's not easy to do it, because what you would have to do would be to actually write the code of the snapshot before you write the component, which is not something that is possible right now. But you don't actually, personally, when I build components, I don't do TDD. I do TDD like most of the time, but they're not when I build components, because components should be simple, and then you only want to know if you did something by mistake, if you change the output of the component. But for everything else, apart from snapshot testing, Jest is great for TDD as well.
Thank you very much. And thank you very much, Michele.
Thank you.
Write more tests. Have fun.